I've been working on this Macropad behind the scenes for most of 2025 and it's finally time to reveal it. It has 6 programmable buttons, a ring of 20 RGB LEDs, a display for button labels and icons, it can store up to 256 different profiles and it even has a programmable scroll wheel with haptic feedback. I'll show you the features properly later in the video, but first, here's why I built it. I use a lot of different software when I'm working on these projects. SolidWorks for my designs, Fusion for toolpathing, KiCad for PCBs, DaVinci for video editing, and the list goes on. But there's one thing that all of these programs have in common, and that's shortcut keys. I'm a big fan of using shortcut keys as I find they save me a lot of time compared to trying to find the buttons on screen. Now, I don't know about you guys, but the problem I have with that is if I haven't used a program in a while, I tend to forget the combinations for those shortcuts. So I wanted something that could store as many key combinations as I wanted and also label the buttons so I can easily identify what they do. There are already loads of Macropads on the market, but there are surprisingly few I was able to find that allow you to dynamically label the buttons. The Stream Deck is obviously a strong contender in this category, but it's 2026 and I'm so done with needing accounts and companion apps to get everything to work. I just wanted something that could be configured the way I wanted, that would store the configuration locally and just function as a regular old keyboard and mouse when it's plugged in with no special drivers required. That's why I decided to just do it myself. To get the build started, I'm going to need some PCBs, and that's where today's sponsor really comes in handy. Whether it's 3D printing, sheet metal fabrication, PCB manufacturing and assembly, injection molding, or even CNC machining, PCBWay has you covered. Getting parts like these PCBs made is a super simple process. Just upload the Gerber files, set a quantity, color, and any special features you might need, and that's it. PCBWay have been helping me bring all of these projects to life, so make sure you check them out at the link in the video description next time you need their services. Now, let's talk about the hardware. First off, I needed some switches. I'm a big fan of proper mechanical key switches, so I knew I had to use them for the macro buttons. In order for them to fit where I needed them to, they had to be low profile switches, so I ended up settling on these Kailh chalk brown switches because they're low profile, relatively cheap, and widely available. There's a couple of different strengths available in this style of switch too, so you can choose whichever one you'd like as long as it uses the same footprint. The keen-eyed among you will have already spotted the RGB LEDs. These are just WS2811s with some 0.1 UF capacitors. Apart from the profile buttons, which even though they are surface mount are easily hand soldered, these LEDs are the only other bit of surface mount soldering in the project. I ended up manually tinning the pads with my soldering iron and then heating the board with my little hot plate to solder on the LEDs. These don't respond well to hot air soldering, but they can be hand soldered if you're really keen. Otherwise, if you aren't a big fan of LEDs anyway, you can just leave them off to make the project easier. Next up is the screen. I went through so many different screen options while I was working on this design. First, I thought of using a little 0.96 inch screen like the ones I used on the NUC Deck Power Management for each of the buttons. I was actually planning on integrating the screen on top of the button for a Stream Deck-like appearance, but I was worried about the longevity of the ribbon cables having to flex back and forth when the buttons were pressed. Plus it meant the buttons were going to be a fair bit bigger than regular keycaps, which I didn't love. Next, I considered using one of the little color TFT screens that are often sold as part of an Arduino starter kit. These have more than enough resolution, but I find they can be a bit lacking in the contrast department, especially in bright environments. I'm also really trying to limit the number of distracting color screens that are in front of me, so I'd rather keep it boring and monochrome if possible. This thing needs to be a productivity tool first, more than a fidget toy. I liked the idea of trying an e-ink display too, but I've never worked with them before and finding one that was about the right width for the number of buttons I wanted was proving a challenge. That's when I stumbled across these 2.42 inch monochrome OLED displays. It's a pretty low resolution at just 128 by 64, but it's got fantastic contrast and the big chunky pixels give it a great retro feel, so I think this is the screen I'll go with. They also come in a variety of colors, so if you don't like the white one that I've gone with, I've also seen them in yellow, green and blue. Now, time for the wheel. A few years ago, a YouTuber called ScottBez1 uploaded a short 2-minute long video showing off his haptic input node. So far, it's had about 2.5 million views, so if you're watching this video, I reckon there's a pretty good chance you've already seen that video. It was such a cool concept that I just had to make the scroll wheel for this project into a haptic knob. The problem with that is to be able to drive the kind of motor we need, you need a pretty fast microcontroller. Since we're also going to be doing a fair bit of other stuff with the microcontroller, I think a dual core microcontroller is a must for this project, so I can offload all of the motor control code onto a separate core. The Raspberry Pi Pico is about as cheap as dual-core microcontrollers get, and it has enough I/O and processing power to do everything that I need, so that's what I'll use. I ended up with a special version of the Pico made by Waveshare called the RP2040 Plus, simply because it has a USB-C port, whilst the genuine Pico is stuck in 2007 with its micro USB. The pinout is exactly the same between the two, so if the regular Pico ever gets an update to USB-C, that should work with this design too. In order to store potentially hundreds of different programs worth of button icons, I'm going to need a bit more storage space than the Pico has to offer, so I included a micro SD reader which will allow us to easily store all of the hardware configuration files and the icons on the SD card. Last but not least, we need a way to actually drive the motor. Fortunately enough, you can now buy the same motor controller that Scott used on a ready-made board from SparkFun. It's not cheap, but the TMC 6300 motor controller IC is tiny and it would be a challenging soldering job for most people, so this makes it much easier for us. The only other parts needed for our haptic knob are a brushless motor and some sort of encoder. I ended up using the same magnetic encoder that I used on the force feedback wheel video from early last year, along with this brushless gimbal motor, which was nice and cheap and should provide more than enough power for our wheel. I've included a guide on the GitHub page for how the two PCBs should be connected together, so I won't bother going into detail here. Now, with all of the electronics sorted, I just need to build it. Okay, to finish it off, now we just need some keycaps and a knob. The keycaps are straightforward to install. They just push into the switches like this. The knob did have me stumped for quite a while though. I wanted to be able to easily install it from the front without having any fasteners visible, and it took me quite a few different ideas before I finally settled on this one. First, I'll bolt this 3D printed adapter plate to the top of the motor. It has some 6x1 magnets glued into it to help hold the wheel in place. Now, all I need to do is glue a matching pair of magnets into the wheel and it will snap straight into place, making it nice and easy to change. The wheel also has the mounting plate shape in the back, so we aren't just relying on the magnets to keep it aligned, meaning even with the motor power turned right up, it won't slip. The keycaps and the wheel are so easy to change now that you could even have a different colour set for every day of the week. You could even go completely overboard like I did and have PCBWay make a complete set of the housing and the buttons in anodized aluminium for that extra premium finish. The heavier wheel will require some tweaks to the PID tuning, but I'll show you how that works in a minute. First, we need to flash some code. One of the big advantages of the Pico is that we can write to it like it's a USB drive. That means that to get this project working, all you have to do is hold the boot button on the Pico when you connect it to the computer, and then just copy and paste the UF2 file I've provided onto the Pico's memory. And that's it. Now, with the config files and icons loaded onto a memory card, it should just boot up and work. Now, let me show you some of the features. There are 6 programmable macro buttons in total. Each macro button can perform up to 3 separate actions for a single button press with configurable delays between the actions. For example, the break command I've assigned here for DaVinci presses the control key followed by the B key to cut footage with the blade edit tool. All 6 of these buttons are custom to this profile only, meaning you can program a total of 1,536 different macro buttons across all 256 profiles if you wish. On the screen, every macro button can also display a 15 by 15 pixel icon along with its label to help make the commands as clear as possible. These icons are just a 2-color bitmap file that gets loaded onto the SD card in a folder of the profile's name. The images are labeled 1 through to 6 so that we don't have to specify file names for every single icon across every profile. The jog wheel currently supports 3 different modes. There's a regular notchy scroll mode where the mouse scrolls 1 line for every click, a center sprung mode where the mouse will scroll faster the further you turn the wheel from its initial position, and finally, just a free spinning mode where the controller watches for your input and then spins the motor a little bit to simulate momentum. Each profile can be assigned one of these modes, so it doesn't have to be the same across all of your profiles. If you have any ideas of a cool wheel mode I might be able to implement, please make sure you let me know in the comments. The wheel can also be configured to hold a button whenever it's in use. For example, in DaVinci, my wheel is set to hold the control button when I turn it to jog back and forth through the timeline. This is also a per profile setting. There are currently 6 different modes for the LEDs: breathe, bands, halo, rainbow, solid, and off. This is just a universal setting currently and won't change between profiles, but I may update that in the future. These can also be configured through the config file along with the primary and secondary colors used in the effects, but I'll get to the config file in a minute. The last thing I need to show you is the profile switching. The 2 buttons above the wheel just jump forwards and backwards through the list of profiles. If you think this is going to be a painful way to navigate up to 256 different profiles, I'd say you're probably right, but don't worry, I've already thought of that. If you hold down either of these buttons, a full profile list will show up on the screen and you can use the jog wheel to quickly scroll through the list and then select the profile you want by pressing either one of the 2 buttons again. When you change the profiles, the Macropad will also write a little file to the SD card to remind itself which profile you'd selected so that it can come straight back to that one the next time it's powered on. And that's it for the features. No menus, no settings to play around with on the device. Once it's set up, it's just a productivity tool. There's nothing there to fiddle with and take away your attention from the actual task at hand. Now, how do you actually configure this thing? A simple XML file, that's it. All of the settings for the LEDs and the PID tuning for the jog wheel, along with the profiles and the macro buttons, are all stored in a single XML file that you can edit in any text editor and just copy onto the SD card. I've included a full guide on the GitHub page on how to edit this file and set up your SD card correctly, but basically just use this key code tester website to work out what key code you want for your macro button and then copy it into one of the actions of that macro button in the XML file along with a delay if you want it, and that's it. It's that easy. All of the files are up already on GitHub so you can get started on building your own. Sorry it's been a while since the last upload. I took a bit of a detour from this project and built an entire camera slider to get some of the cool shots for this video. It ended up being quite a project on its own. If that's something you'd like to see a video about, let me know in the comments. I've got a big project coming up at the start of this year that I can hardly wait to get started on, so make sure you subscribe so you don't miss it. Thanks for watching.